Well, good afternoon, everybody. Welcome to this month's EnviSMART. My name's Brad Clark. I'm an academic at the University of Melbourne. To start the meeting, I'd like to pay our respects to the traditional owners on the lands in which we meet and pay our respects to the elders past, present and emerging. And Mandy's joining us from some of the areas that have been flooded. So our thoughts are actually also with the people up there who've had been impacted by some extreme weather events over the past few months, and looks very terrible on the news. Also like to acknowledge the support that we've been receiving to run these events, and really do appreciate the various organisations that are helping us put this on. So Agilent and Eurofins, and we've partnered with these other organisations, the Australian Contaminated Land Consultants Association, Water Research Australia and CTAC, both Australasia and Asia Pacific. Appreciate that support, and maybe Amanda might say more on that later. And we're also supported by Trajan and PM Separations. We've got a pretty awesome program set up for the entire year, actually, which I'm going to just quickly advertise now, or the next few talks. For next month, actually, we've got Dennis Helsel, who is from the USGS, or he's retired now, but he does a lot of environmental statistics. And in particular, he's really interested in censored data. So all those values below your detection limit and how you treat them to provide meaningful outcomes. So join us then. It's actually going to be a 10 a.m. meeting, and that's because he's joining us from America. After that, we've got we're going to have our speaker from Europe, and she's for anyone who does ecotox work, she's done a lot of work on developing harmonization and criteria for making sure that the ecotox data that we generate is useful for particularly for comparison regulatory settings. Then going back to America after that, we got Michelle Hadlick from the USGS as well, and she's going to talk to us all about neonicotinoids and their impact on bees. And then we've got Jenny Storber in July. All of those events are up on Eventbrite, so if you'd like to come along, just register in the same way that you've done for this one. And I'm going to quickly get out of the way, and we'll get on with our great talk today. And so we have today the current president of the Asia Pacific CTAC, Amanda Reichelt-Brushett. And she's going to, from Southern Cross University, and she's going to talk to us about Mercury and the artisanal mining gold rush in the Buru Islands in Indonesia. And we'll try to have about 10 minutes of questions at the end of this. So you can either put your questions in the chat, or you can also raise your hand through the icons when we finish and ask a question. Ideally, turn your camera on and your microphone and ask that question. So without further ado, I'll stop my share and hand over to Mandy.
Thanks, Brad. I'm still on share, so have you got a...
Yeah, we can see it. Yeah, it's all good.
Oh, good. Okay, fabulous. Thank you. And thank you for the invitation to present. It's really interesting, these EnviSMART presentations, and really nice to see that it's rolled on over times where we've not had opportunity to connect with each other in other ways. Some of you may have seen much of this presentation if you're at the Mercury Symposium late last year, so apologies for that. I always give my presentation slightly different, so if you have seen it, maybe stick around and you might catch a little bit more. But before I go ahead, I've got to give a plug to CTAC Asia Pacific, which CTAC Australasia is a very important chapter. But we do have a virtual conference coming up. So please save the date. It's September the 5th to the 8th. It's the same time as the World Congress was planned, which has now been postponed. We plan to have a website up next week, and there'll be a call for special sessions there. So really hope to see lots of exciting special session proposals that we can incorporate into the program. We've got a great group of volunteers and as part of the organising committee, but if you're still interested, I'm happy to hear from you. There's always a spot for more volunteers in every project that you do. So yeah, please drop me a line if you are interested. But right now, I probably want to take you north and we'll go on a little bit of a world trip. You can see the map of Australia there, and the place where we'll be focused on today is an island called Buru Island, which is just highlighted there. Do you see my cursor, just for reference?
Yes, we do.
Okay, thank you. A bit of reference over here is Bali. So a lot of people know Bali. So we're much further east than Bali. Raja Ampat is here. This is the hotspot of coral biodiversity in the world. And this area is part of the Coral Triangle, which also goes north and includes the Philippines. So the provincial region in where we work is called Moluccas Island. Buru Island is not far from Ambon, which is the capital of Moluccas Island. And a lot of the photographs and imagery you're going to see are from Buru Island. The bay here is called Namlia. And this is where the ferries and so on and a lot of the transport happens to Buru Island. There's two main mine sites. Gogria is here, and I'll talk to that a lot. And there's also Mount Botak, which is interpreted as Bold Mountain in English, and there's some more mining that occurs down here. Most of the work we'll be looking at today is based on the Gogria mine site and some work on Botak Mountain, and we've also been looking at mercury in fish samples in the marine system here. So artisanal and small-scale gold mining using mercury only commenced on Buru Island in 2011, so just over a decade. Gold was discovered in 2010 and sort of created a bit of a gold rush, like we can, has been documented in places like Ballarat and Victoria. This is Namlia, I just mentioned. This is the bay, part of the bay that the ferries come into. And one of the important things about the Moluccas province is that it's made up of many, many islands, and they're very small. Only 7% of the provincial area is land. So that means that a great deal of the protein resources that the community use comes from the marine environment. And fishermen live and breathe the marine environment. And these houses are set up at the mouth of the Wayapo River. And you can see there's fishing nets here. There's some fish being dried here. But these drums, most houses have these drums out the front. It's where they collect their fresh water from when the tide is low and there's a very low salinity in the water, and that fresh water is used in the housing. Just something there to keep of note when we talk through the distribution of mercury in the environment. So this is a Gogria mine site pre-mining in 2010, and by 2013 it looked like this. It's made up of many individual mine shafts that are leased by the landowners, by miners that have often come from other islands that have some experience in mining operations. When you have a closer look at what they look like, under each one of those tarps is a lease. There's a shaft, and people literally go down to the shaft and dig the material out and bring it up on these ropes, which are tied to wheels. Obviously you need to breathe down there, so this is the breathing apparatus that is used to get fresh air down into the mine shaft, and these can be up to 20 meters deep, and at times, you know, they move horizontally as well, and there's potential collapses in the mine site, and people run into a little bit of warfare down there when they run into each other's mine shafts as well. So these are really quite remote and rugged and hard to access locations. So there's a very big occupation associated with carting the mined material down from those locations to sites where the ore is processed using mercury to extract the gold from. Obviously, and I'll explain a bit more, but that process requires a lot of water, and a lot of those trommel sites, as we call them, are based on close to water and river systems. So just a point of reference here, and one of the things I want to highlight in this presentation is not just the scientific aspects of a gold rush and mercury use and small-scale gold mining, but also some of the social aspects. And there's a lot of money being carted on the shoulders of these people, because the average gold concentration in the ore bodies is around about 1,400 milligrams per kilogram. So that amounts to about 30 grams of gold per bag. And when you're thinking about gold being about $50 per gram, each one of those bags is worth quite a lot of money. And there's a important human resource associated with carrying these bags, and the people that make a living from this, or were making a living from this, were earning more money than school teachers and farmers. So it led to a movement of people in sort of socially stable occupations and community occupations to work in the mine sites. And you can see there's tags around these people's necks, and that means they all had to have permits and approvals to be part of those operations. Also, on another part of the social aspects of small-scale gold mining is it creates an enormous amount of community wealth. And what happens is that a large mining company might employ people to be involved in a mining operation, but these people are actually the profiteers. And on the left, you can see that that's sort of a pretty nice, normal house on Buru Island. It was traditionally part of the national granary and contributed a lot of rice to the supply of Indonesian rice to the whole of Indonesia. But as a result of the influx of income associated with gold mining, people became very wealthy, and they were allowed to realize that wealth not only in education and health, but also in possessions and as you can see on the right side, some pretty immaculate housing. Interesting enough, though, there's still very limited electricity and sewage facilities and things like that. In the processing operations, they're small, as you imagine, small scale. They require that the ore is broken down into a really fine powder. And that's done using trommels. And these are often a family affair. You'll have a family involved in a trommel operation. And on the picture on the top right, you can see a fellow using a bottle, but in those bottles is a certain volume of mercury, which is put into the trommel after the ore's been crushed. Then it's trommeled for another several hours. And after that, the mercury amalgam is collected. The waste is usually contained in the bottom right picture here. The waste is usually contained in open retention ponds, and those are often drained with little divots that go down into the river system and take the water overload away from those retention ponds. So mercury is often bought on the black market, and I'll talk to that at the end of this presentation, but about 20 to 30% of that is lost in tailings. And a point that a lot of artisanal mine researchers consider is as an incentive to minimize mercury input into the environment. An incentive could be about retaining it and ensuring you don't lose a lot of money with your with the tailings that include a large proportion of a high cost material associated with the operations, which is mercury. So just a little bit of a closer look at these trommels. There's several thousands of them dotted across the landscape. And here on the top right, you can see that trommel is being drained out, and because the mercury amalgam is very heavy, it sits in the bottom, remains there, and people collect it. And once it's collected, it's sort of this mercury amalgam you can see here in the blue bowl. And I'll just run this video, which just shows a little bit of the processing. Amalgam is collected by individuals. Just a bit of note on the WHS there. And then it's squeezed and it forms quite a solid amalgam. And from there, that amalgam is collected and it's burned, the mercury is burnt off. So there's another pathway of mercury loss through the atmosphere as a result of this process. And this is just a small, handmade, what you might call a fume hood. And you can see that the mercury is being burnt off here. Another thing you might want to notice, the WHS and the fact that children are really exposed to these environments because they're living and breathing in the mine site, in the processing site themselves. Some effort does get put into setting up fume hoods, and you can see the fume hood on the left here, a homemade fume hood, and this is on the inside of the fume hood, and you can see there's an attempt at making a high surface area to capture the volatile mercury, and you can see that sort of white dusty powder. That's mercury deposition after the process of burning the mercury off from the gold has occurred. So obviously this was a very interesting concern, and my collaborator Yusmali, who is also named on this presentation, joined with me. He was part of a funded program to come to Australia to do some study, and it was by chance that he had collected some samples from these sites. So one of the projects he was working on initially, we were working on together, is just to have a look, well, how much mercury is in some of these samples that he had collected. So in the Goghria mine site, the trommel waste, we measured over 200 milligrams per kilogram of mercury, and at the Botak mine site, there were concentrations up to 870 milligrams per litre. And those concentrations are in the order of what was found, or as high as what was found in the most contaminated sites in Minamata. Obviously, that's quite alarming, and it really precipitated more study, but there's very little funding to focus on projects like this. So we spent, time clamoring together a few $1,000s here and there and some travel grants here and there to keep this project alive and going. I managed to publish several papers out of it, and we've also got some ecotox publications associated with this mine waste and sediment ecotox work, which I'm not presenting today, but just part of a further work that we've done. You can see here that there's a lot of deposition from the different mining operations, and this bridge is an interesting example. These are abandoned trommel sites, and used to be about 10 feet before the water on that bridge. So there's a lot of sediment movement in these areas. So in our study of looking at mercury in marine sediments, so we went around that Namlia Bay, and we looked at some tributaries to the river. And back in 2012, these samples were collected. It was quite alarming that even though the mining had only been occurring for a year or so, right in the offshore area of the river mouth, we detected some very high concentrations of mercury in the sediment, up to 3 milligrams per kilogram. noting that normal sediments contain only about 0.02 milligrams per kilogram. And Just did some sort of sequential extractions because we had very limited material at the time, just to look at the different availability of the phases. So remember, like I say, that was in 2011, those samples collected, and we were able to go back in 2014 and have a look at some of the same sites at least. And this particular site in 2014, we measured 47 milligrams per kilogram of mercury in the sediments in that delta area of the river mouth, which again is even more alarming. Which obviously leads you to the question about where is this mercury going through the food chain? Are organisms taking it up? Is it in the food chain? And is there a threat to food safety? Noting that a lot of the community, a large proportion of the protein comes from these marine resources. So there's a couple of star species. Just point you to this picture on the top here with this man collecting whelks for consumption. And this fish here, I'll highlight that in a little while. It's called a snakefish, obviously by the way it looks, but its species name is Channa striata. Another thing I want to highlight is that people really do all sorts of things to just artisanal fish as well. So in the picture on the right here, there's a fellow who happens to have an electrofisher, and he's working in the channels around the roads and where some of that trauma waste is going to catch a feed using his electrofisher. So what we measured in some samples that we collected from fish markets on Buru Island was that, yes, indeed, there is mercury. This is total mercury concentrations. And this Channa striata species, which is more of an estuarine than a marine species, really had a very high body burden and mercury concentrations of up to 3 or just over 3 milligrams per kilogram. We also note that the species that did exceed those guidelines in the red were predominantly carnivorous species. So there's certainly suggestion that there's food chain transfer. We also looked at some prawns, and a few points to note is like these very small ones are usually cooked up in fry and they're not peeled. So we didn't peel them in our processing because we wanted to process them the way they were eaten. So again, we found some elevated mercury concentrations in crustaceans and a similar pattern in mollusk species, and particularly this species here had a very high concentration, relatively high concentration of mercury. So how do we process all these samples? Or you have to get approval to bring samples in. So you have quarantine permits. We bring them into quarantine laboratories. We had to get them irradiated before we were allowed to process them in the lab. And other times we've actually brought the lab into the quarantine room and done the processing there rather than have to transport samples to the irradiation facilities to meet our quarantine requirements. And in 2014, we were lucky enough to get some ARC LEAF funding to couple ICPMS with HPLC. So we were able to do some mercury speciation with our next step of the work that we were doing. And this was a pretty exciting opportunity to really start looking at not just total mercury, but methyl mercury as well. Although it's important to note that a lot of the guideline values are based on total mercury concentrations themselves. So also in 2019, we got some funding from New Colombo program to bring some students from Australia, from Southern Cross University, on an exchange, so they were able to have an Indonesian experience, and part of their experience was going to these mine sites. But they also had a task where they had to go to fish markets in Ambon and fish markets on Buru Island, and we processed those samples, organised them to get them sent back to Australia. So we sent them back to Australia, and there was a big concern because Ambon's not that far from Buru Island, that the community on Ambon were saying, well, is fish in our fish markets going to have mercury in it too? So it was a big community question that we helped answer. And we also wanted to do some comparison between what's in the fish from and seafood in fish markets on Buru Island. And we looked at total mercury concentrations, but we also were able to look at the relative ratio of mercury compared to methyl mercury. And you can see here in the Ambon Island fish, our big predatory fish that you would probably expect to see some elevation in mercury was certainly there. And that's why we have those food safety criteria, for example, of 2 fish meals per week of marlin or tuna or those large predatory fish. And you can also see that pattern. Now that's probably natural biomagnification. These tuna are carnivorous, and we know there's an elevated mercury load in those fish. But we also found other species that had very high loads of mercury in them. And we were able to sort of determine that 50 to virtually 100% of the total methyl mercury load was, of the total mercury load was methyl mercury. So that has been used with the provincial governance, and so has our previous data. It's been used with provincial governments to actually enact a banning of small-scale gold mining and processing on Buru Island. So it had a very tangible outcome. And what has happened is that mine site in 2019 is virtually abandoned. And when we went there in 2019, as a result of all those mine shafts that you saw in those earlier pictures and the heavy tropical rainfall that has occurred naturally occurs in the area, there's been some major landslides. Obviously those mine shafts get full with water and destabilize the environment and act as a lubricant, really, to result in landslides, where keep in mind that this is the ore, it's not the processing material that's got a lot of mercury in it, but there's also areas where the processing facilities have been impacted as well. Obviously, you get a lot of movement off-site with a high rainfall region as well. So these are the signs that you see today. Mining activities are prohibited. You can get 10 years in prison or a pretty hefty fine. And even if you're using hazardous chemicals such as mercury and cyanide without permission, you can get a penalty of 4 years prison or a similar or same fine. So that has really put a big halt to the mining operations, but there's loopholes or splitting hairs, as I note in the slide there, where those bans were put in place at the particular areas of the mine site, and people have gone, well, I'm going to mine over here now because you didn't exclude mining from those operations. So there's still mining that is being conducted, and there's still a challenge associated with that, although the gold rush, as you'd call it, is not nearly as prevalent as it has been in the past. But the legacy of that gold rush and the thousands of unmapped trommel sites still exists. They haven't been mapped. And over time, you know, the grass will grow, the trees will grow, and those trommel sites won't be identifiable as trommel sites anymore. And people may choose to live there, they may choose to farm there and conduct agriculture. So I think there's a very important legacy issue and a continuing, although smaller, issue associated with mercury pollution on Buru Island. One of the challenges in terms of managing it is we all probably know that mercury is an internationally controlled substance, but it happens to be in Indonesia in a place called Seram Island, which is, you can see on the map here on the bottom right, our little black spot or a little black square there is just popping out into this big map. But there is a cinnabar mine in a place called Hulong on that peninsula of Seram, and cinnabar is HGS, which is one of the raw materials that's used to extract elemental mercury from. So they literally have an internal closed loop for the sources of mercury and the process of artisanal gold mining using mercury. So over on Cinnabar Island, you see a similar thing happening. This is small scale mercury mining, very similar operations. A lot of gravity is used to separate the very heavy cinnabar, which is then transported to Java for processing to form elemental mercury. So lots of challenges, but not only scientific challenges and environmental challenges, but social challenges, community challenges, and just wanted to sort of present you a bit of a documentary story on some of my research experiences in the last decade. So I really would love to have questions and answer questions. So don't feel shy, reach out, ask questions, and hopefully I can answer them. And I'm just going to move to one more slide and double plug our conference that's coming up in September.
Thanks very much, Mandy, and that was fantastic.